I wish to welcome our guests who are already joined us. Dr. Shashidhar Bhatt sir has also joined. Welcome to you, sir. And our speaker, Dr. Gurumurthy Hegde sir has joined. Welcome to you, sir. We will start very soon in another 2 or 3 minutes. I can also see past President Rotarian Ravichandra sir. Warm welcome to you, sir.
Thank you, Srinidhi.
Thank you for your support always, sir. Rotractor Arpita and Rotractor Navya, are we ready to start?
Yes, sir.
Yes, sir.
Shall we start, sir?
Yes, please.
Little things make big life. Great things are not done by impulse, but by a series of small things brought together. A very good evening and warm greetings to one and all present here. Rotaract Club of Bangalore Sheshajipuram, in association with Department of PG Studies in Physics, Alvas College, Mudubidre, Karnataka, and School of Civil Engineering, Reva University, presents to you all Honorary Dr. APJ Abdul Kalam Memorial Lecture 2021. As our active supporters for this program, we have Department of ECE, HR Institute of Technology, Bangalore, Karnataka Science and Technology Academy, Royal Concord PU College, Kalyan Nagar, Arena Animation, Bagalur, and ThinkWorks Games and Animation. Extending a very warm gratitude to all our collaborators and supporters. There's plenty of room at the bottom. In December of 1959, the world witnessed this statement at the American Physical Society, Caltech. In this famous lecture, Richard Feynman laid the conceptual foundations for the field now called nanotech, when he imagined a day when things could be miniaturized. Nanotechnology in general is the study and application of extremely small things and can be used across all other fields of science such as chemistry, biology, physics, material sciences, food sciences, engineering, etc. And this very interesting field is chosen as our theme for Dr. APJ Abdul Kalam Memorial Lecture 2021, Nanotechnology, Research and Innovation. In today's session, let's try to gain more insights towards this emerging and enthralling field of science and technology. Asatoma Sadgamaya Tamasoma Jyotirgamaya. Let's make this evening a very blessed one by kindling the lamp of knowledge and wisdom. Over to you, Retractor Srinidhi Sir, Club Mentor and past President of RCBS.
Dr. Navya, please unmute yourself.
So sorry for that. Thank you, Srinidhi Sir. Before we start off, a few general instructions for our lovely audience. Please stay on mute to avoid voice disturbances. And also, please feel free to put up your questions or queries, if any, in the chat box. We will be running a poll questions or a kind of quiz at the end of this session. It would be nice for all of you to stay till the end to answer the poll questions. And also, there will be a feedback form shared at the end of the session to be filled up for certificates. So I request you all to stay till the end of the session. As we kick off today's session, I would like to call upon Retractor Sandesh Casey to administer the rotary four-way test. Over to you, Sandesh.
Am I audible?
Oh, yes, Sandesh.
Good evening, one and all present here. It's my privilege to administer you all the rotary four-way test. Let us adhere to the rotary four-way test in our daily life, in every step of life. Kindly repeat it in your mind as I recite. The rotary four-way test of the things we think, say, or do. First, is it truth? Second, is it fair to all concerned? Third, we build goodwill and better friendship. Fourth, will it be beneficial to the all concerned? Thank you.
Thank you, Sandesh. Now, I request our Club General Secretary, Retractor Rakshit K. Shetty of RCBS to welcome today's gathering. Over to you, Rakshit.
Thank you, Naveshri. Very good evening to each one of you present here. On behalf of the President, Dr. Lavanya, and all the members of RCBS, I take the honor of welcoming the distinguished speakers of the evening, Dr. Brumurthy Hegde sir, Professor C.N.R. Rao, Chair Professor, BMS College of Engineering, and Professor Venkateswarlu Dasari sir, Assistant Professor, Department of Physics, Atria Institute of Technology. A hearty welcome, professors. I now welcome the guest of honor of the event, Dr. Shashidhar Bhatt, Coordinator, Department of PG Studies in Physics, Alvas College, Moodbidre. Dr. Y. Ramalinga Reddy sir, Associate Dean and Director, School of Civil Engineering, Reva University, and Rotarian Mirabai Shankar ma'am, Club Advisor and Trainer, Rotary Club of Bangalore, Seshadripuram. Pleased to have you all. I welcome the President of Rotary Club of Bangalore, Seshadripuram, Rotary Lavanya to the event. Welcome, President. I also welcome past President, Rotary Srinidhi SU, Club Mentor and Project Chair, Dr. APJ Abdul Kalam Memorial Lecture. Welcome, sir. I also welcome Dr. A.M. Ramesh, sir, the CEO of the Karnataka Science and Technology Academy, Government of Karnataka. Thank you, sir. A warm welcome to the Board of Directors and members of Rotary Club of Bangalore, Seshadripuram. A warm welcome to all our collaborators and supporters. Department of PG Studies in Physics, Alvas College, Moodbidre, School of Civil Engineering, Reva University, Department of ECE, Atria Institute of Technology, Karnataka Science and Technology Academy, Royal Concord PU College, Kalyan Nagar, Arena Animation, Bangalore, and ThinkWorks Games and Animation. And a very warm welcome to all our participants who have joined us to witness the 4th annual session of Dr. APJ Abdul Kalam Memorial Lecture. Thank you all. I'll hand it over to the moderators.
Thank you, Rakshit. That was indeed a very warm welcome. Now, to deliver a brief talk on Honorary Dr. APJ Abdul Kalam, sir, I call upon Retractor Arpita Kumar. Over to you, Arpita.
Good evening to one and all present here. I'd like to take the honor of expressing a few words about the great Bharat Ratna, Dr. APJ Abdul Kalam. Dream, dream, dream. Dreams transform into thoughts, and thoughts result in actions. Abul Paikar, Jain Alabdin Abdul Kalam, 15th October 1931 to 27th July 2015, was an Indian aerospace scientist who served as the 11th President of India from 2002 to 2007. He was born and raised in Rameshwaram, Tamil Nadu, and studied physics and aerospace engineering. He spent the next 4 decades as a scientist and science administrator, mainly at the Defense Research and Development Organization, DRDO, and Indian Space Research Organization, ISRO, and was intimately involved in India's civilian space program and military missile development efforts. He thus came to be known as the Missile Man of India for his work on the development of ballistic missile and launch vehicle technology. He also played a pivotal organizational, technical, and political role in India's Pokhran II nuclear test in 1998, the first since the original nuclear test by India in 1974. Kalam was elected in 2002 as president and is widely referred to as the people's president. And he returned to his civilian life of education, writing, and public service after a single term. He was a recipient of several prestigious awards, including the Bharat Ratna, India's highest civilian award. Kalam received 7 honorary doctorates from 40 universities. Thank you.
Thank you, Retractor Arpita. Indeed, honored to have heard about sir. Now, I call upon Retractor Srinidhi, sir, to give a brief about the memorial lecture. Over to you, sir.
Thank you. Gurubhyo Namaha. Many of us have a role model whom we wish to follow, whom we wish to always keep in our mind in any kind of decisions or in any kind of thoughts. So to many of us, it is Dr. APJ Abdul Kalam indeed. So the concept of having a memorial lecture dates back to 2018 when we let Dr. APJ Abdul Kalam stay in the mind of all the youngsters. Rotaract being a youth organization, we should never forget a person who stood as a strong pillar and supported the field of science, literature, politics, and infinitely, I would say, the entire India. So Dr. APJ Abdul Kalam Memorial Lecture was initiated in 2018, and every year we thought of having a theme. And this was majorly to concentrate more on the concept of science and technology. So the first year we had it on Innovative India, where Professor Dr. Muniratnam from Associate Professor of Department of Physics, Reva University, and myself, we both were the resource persons of the first inaugural session of Dr. APJ Abdul Kalam Memorial Lecture, which was attended by over 150 students from the Bright School. The second session was in association with Reva University School of Basic Studies, Basic Sciences, where Professor Beena Ma'am was the chief guest, and we had Professor Marada sir and Mr. Ranganathan Narayanan as the resource persons. The third session was in association with Department of Civil Engineering, Atria Institute of Technology, and we had 2 prolific resource persons, I would say Colonel Narasimhan sir and Professor Sudhendra Haldoderi sir. Unfortunately, we lost Professor Sudhendra Haldoderi sir recently, and the theme of the year was Defense and Indigenous Technology. So this year's theme was, I would say, a brainchild of our very own resource person of today, Dr. Gurumurthy Hegde sir, who said that one of the themes of this session could be nanotechnology. And we are indeed happy that sir has accepted to be a resource person. So this year's theme is nanotechnology, research and innovation. And on behalf of Rotaract Club of Bangalore, Shesharipuram, and all the other co-organizers of today's event, I welcome you all once again to the Dr. APJ Abdul Kalam Memorial Lecture 2021, the theme of which is nanotechnology, research and innovation. Once again, welcome to you all, and I hand it back to the moderators.
Thank you, sir. As we plunge into the main part of today's session, I would like to call upon Retractor Pranav to introduce our distinguished speaker for the day, Dr. Gurumurthy Hegde, sir, Professor, CNR Rao Chair Professor, BMS College of Engineering. Over to you, Pranav.
Thank you. Professor Dr. Gurumurthy Hegde started his life in academia in Mangalore University, where he finished his BSc in physics and later completed his MSc in material science. He later went on to complete his PhD in physics at the CSIR laboratory on the topic of photo-induced effects in liquid crystals. He then became a postdoctoral researcher at the Hong Kong University of Science and Technology and then the Gothenburg University in Sweden. Professor Hegde acted as a visiting scientist in the Hong Kong University of Science and Technology for a brief amount of time before becoming the visiting professor at the BMS R&D Center for half a year. He then went on to become an assistant professor in the University Malaysia Pahang for 4 years. Since then, he has been selected as the Professor CNR Rao Chair Professor in the BMS R&D Center and has been a professor since January 2020. Professor Hegde has won a plethora of medals in countries ranging from the USA to Japan, South Korea, and Malaysia. He was also given the Sir C.V. Raman Young Scientist Award from the Government of Karnataka in the year 2017. Professor Hegde has been a senior member of the Institute of Electrical and Electronics Engineers, or IEEE, since 2018, and has been the chairman of the SID Bangalore chapter since 2017. As a researcher, he has more than 2,000 citations, a H index of 26, and has raised a total of $2.3 million for grants. Let us now warmly welcome Professor Dr. Gurumurthy Hegde to address the gathering.
Thank you, Pranav. It was indeed a very inspiring introduction to hear from. The session is over to you, Gurumurthy, sir. We are keenly waiting to hear from you.
Good evening, everyone. And first of all, I would like to thank Rotaract Club and especially Srinidhi for inviting me here. It's really nice to deliver Abdul Kalam lecture on his special day, which we can't forget because the contribution which Dr. APJ Abdul Kalam gave to Indian science it's never forgettable, because he's the person who is the best example for how to be down to earth in nature, because we all having headweight for whatever we are having little bit, but with all his credentials, with all his awards and knowledge, still he is down to earth. He's a president for common people, and so many medals and so many awards to his credits. So I think he's one of the greatest scientists the country has ever seen in the history of science and technology. So I will share my screen and I will start my presentation. I hope you all, can you see my screen?
Yes, sir, we can.
Yes, sir.
Okay, just a minute. Is it visible?
Yes, sir.
Yeah.
Slideshow is visible.
Yeah, but this today's theme, as mentioned by Mr. Srinidhi, that the nanotechnology research and innovation, and in memory of Dr. APJ Abdul Kalam, I thought it is apt to give a lecture on nanotechnology, which is closely related with the farmers. I will tell you what topic I am choosing. Before that, I will give a very nice quote from Dr. APJ Abdul Kalam, where he's told that don't read success stories, you will get only message. Read failure stories, you will get some ideas to get success. This is one of the phenomenal word which we all should follow, because usually whenever we are telling our kids, we always tell them to read the success stories, but success stories will only give you the success, but the failure stories will teach you how, if you become fail, how to make the fail into a success. So with this, I will tell this, because the Dr. APJ Abdul Kalam, he never be considered as a boss in his lifetime. He always considered as a leader. He is the one who is leading from the front, and he will take all others along with him. Even any blame comes, he is the first person to take the blame on him, and he will always protect his scientists. Even for when satellite fails, Dr. APJ Abdul Kalam was the first one to tell that failure is happened because of me. And whenever satellite success will come, he always tells that it is the team success. So that's the quality of a leader. And with that, I'm going to give a lecture today on Areca nut nano, research through innovations and the sustainable economy approach. Why I choose this is mostly whatever the research we are doing, it never be connected with the farmers, because all the research mainly it is starts with the research, end with the publication, again end with publication, start with research. It never goes beyond that. So my purposeful of today's talk is to how to help the farmers, because Areca nut is one of the commercial crop which many of the Indian farmers are completely depending on that. If you visit the Western Ghats like the Shimoga side until to Puttur, then to Kerala, majority of the farmers completely depending on the Areca nut. And why? How to use this Areca nut for the research, and what kind of innovations we can bring to this Areca nut, and then what kind of application we can do along with that. So when I said that, then the question is why innovations is required, because today's theme is all about nanotechnology, where research through innovations. So if you see this picture, it appears like one old lady is looking at her. If you think that it's only one old lady is looking, we always think that the old lady is looking. But the research is completely different. You have to focus your things and you have to open, because when you are doing research, your eyes should be always open. You should have a liberty to accept the challenges, and you have to think deep, and you should have open-mindedness. And the most important thing is you have to search the new things. When I said that this is the old lady, if you open further, you will see the young lady. So this is the combination of old lady and the young lady. The old lady is nothing but the full of experience and full of knowledge, and the young lady is the full of energy. So when you mix this old and new combination together, we can achieve wonder in life. That's all about the nanotechnology research to innovations, where innovations is a part and parcel of life, which requires a lot of encouragement from the youngsters and the hard work and experience from the senior people. So when we're talking about innovations, the major thing is the funding. So this is a very beautiful slide where what are the kind of funding happening in research and development presently. You can see the United States leading with $476 billion, followed by China, $370 billion, and the Japan, $170 billion. And you can see India is still at $48 billion. In spite of our 1.3 billion population, our research and development funding is really almost 10 times lesser than what United States is funding. So because of that, we couldn't able to bring the quality products to the market, which you can say that it is from India, because without funding, you cannot do the research, and without research, you cannot make innovations, and without innovations, you cannot bring any sustainable product to the market. If you see the Indian growth, this is a very beautiful slide given by the Department of Science and Technology in Economic Outlook. It's quite an old slide, but they told that Indian GDP is increasing year by year. So Indian economy is ranks third largest in the world, and soon it becomes the second. It will beat the United States very soon. And it's estimated that in 2050, India might become #1 economy in the world. When you come to the Indian share of global GDP, it's not like it's happened 20 years ago, what happened to India, but the story is completely changed now. So after 20 years, this is the data released in 2013, but definitely I'm sure 2020 is much, much better than this. So India is constantly progressing, whether you take the global GDP, or you take the global manufacturing increase, or you take the share of global merchandise export. Every time India is almost 3 times Indian values are increased. That itself tells that India is going to take a place in a high economy world. And this is why I choose Areca nut as a topic. This is recently our lab is in the news regarding this one. I will just share this to you.
ಜೊತೆಗೆ ಅಡಿಕೆ ಬೆಲೆ ಕುಸಿತ, ಬೆಳೆಗಾರರ ಸಮಸ್ಯೆಗಳು ಗಮನ ಸೆಳೆಯುತ್ತವೆ. ಈಗ ಈ ಎಲ್ಲ ಸಮಸ್ಯೆಗಳಿಗೆ ಪರಿಹಾರ ಕಂಡುಕೊಳ್ಳಲು ವಿಜ್ಞಾನಿಯೊಬ್ಬರು ಸಂಶೋಧನೆ ಕೈಗೊಂಡಿದ್ದು ಇದರಲ್ಲಿ ಭಾಗಶಃ ಯಶಸ್ವಿಯಾಗಿದ್ದಾರೆ. ಬೆಂಗಳೂರಿನ ಖಾಸಗಿ ಎಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜಿನ BS ನಾರಾಯಣ್ ನ್ಯಾನೋ ಮೆಟೀರಿಯಲ್ ಅಂಡ್ ಡಿಸ್ಪ್ಲೇ ವಿಭಾಗದ ಪ್ರಾಧ್ಯಾಪಕ ಡಾಕ್ಟರ್ ಗುರುಮೂರ್ತಿ ಹೆಗಡೆ ಜೊತೆಯಾಗಿ ಅಡಿಕೆಯಿಂದ ನಿತ್ಯ ಜನರು ಬಳಕೆ ಮಾಡುವ ಹಲವು ವಸ್ತುಗಳನ್ನು ತಯಾರಿಸಿ ಅಚ್ಚರಿ ಮೂಡಿಸಿದ್ದಾರೆ. ಅಡಿಕೆಯನ್ನು ನ್ಯಾನೋ ಪಾರ್ಟಿಕಲ್ ಆಗಿ ಪರಿವರ್ತಿಸಿ ಕೆಳಗೆ ಬಿದ್ದರೂ ಒಡೆಯದ ಗಟ್ಟಿ ಮುಟ್ಟಾದ ಗಾಜು, ವಾಹನಗಳ ಬ್ಯಾಟರಿ, ನೆಲ ಸ್ವಚ್ಛಗೊಳಿಸುವ ಮಾರ್ಜಕಗಳಿವೆ. ಹಾಗೆ ಅಡಿಕೆಯಿಂದ ಅಡಿಕೆಯಿಂದ ತಯಾರಿಸಿದಂತಹ ಕಾರ್ಬನ್ ನ್ಯಾನೋ ಮೆಟೀರಿಯಲ್.
So because of that, since everybody is interested in areca nut based product, we thought that we can continue in this research. And before starting that actual topic, I will give a very brief introduction about our center. It's called as BS Narayan Center for Nano Materials and Displays, where you can see the achievements. We received nearly 2 crores so far after I joined this center, and a lot of publications, patents, and we are working on various fields like supercapacitors, catalysis, then waste to wealth technologies, liquid crystal displays, water purification, and so on and so forth. This is the center ongoing activities. We are working in two different directions. The first direction is on liquid crystals and related phenomena, and the second direction is nanomaterials in the application of energy, water, and health. So these are the main equipments present in the center. We have a class 1000 clean room, followed by all the electrochemical workstation and the battery manufacturing facilities. We have a fabrication unit, whether you make a solar cells or you can make it the liquid crystal cells. We have a dedicated chemistry synthetic laboratory, optical laboratory, electro-optic and dielectric laboratory, and polarizing optical microscope laboratory. So when you tell about nano, the size really matters. When I said like size matters, you don't like this size because this is the bulky size. But you like this size, this is a slim size. But the curiosity never ends, because that's why we are all researchers. Our curiosity is we not only want slim, but we also want flexible. So that's how the slim and flexible came. You might wonder why these celebrities are doing with my research. My next slide will tell you about these things. If you see, if you are sitting in 1980s on your table, and if you want to have all the gadgets, whether you take your telephone, whether you take the radio, whether the books, or you take your global map, or you take your newspaper, you don't have any space to write your notes. But as the year progresses, when laptop has been discovered, one by one, these gadgets went inside the laptop, and you have plenty of space available on your table. So that's the power of nanotechnology. When material becomes smaller and smaller, it creates wonder. So it is estimated that in 1980s or 1990s, if you want to go with all the gadgets which is listed here, you have to carry 250 kilograms of luggage with you. But now, just because of nanotechnology, just as 250 grams of your mobile phone is carrying your 250 kilograms of luggage. That's a phenomenal achievement in the area of digital transformation. This all happened because material size becomes smaller and smaller. So why we need to work on nanotechnology? Because of this. The World Health Organization told that humanity's top 10 problem for the next 50 years is this. Because usually whenever problem comes, we are always telling that we have a population is a big problem for India, China, and all. But according to the World Health Organization, population is the 10th biggest problem. The first problem is energy, then water, food, environment, poverty, and also on and so forth. So population is really advantage for a country like India and China, where if you have our own sustainable product, we don't need any other foreign customers. Our own customers are enough to buy our product and make the country economically very rich. Having said that, this is a very important statement. People do not buy the technology, they buy the products. So whenever you visit any shopping mall, you never ask for, you want Apple technology or you want Samsung technology, but you want Apple phones, you want Samsung TVs, because we are just buying the products. We don't want the technology. So when you make a product, always think that our product should go to the poor people, not the rich people. Anyway, if you make a cheap product or the costlier product, the rich people anyway he will buy. So make product for the poor people so that you can cover all the spectrum which is available in the universe. So to do that, to reduce the cost of the devices, only small particles can able to play a dominant role. So many things can happen when material becomes smaller and smaller scales. So when I'm telling about smaller and smaller, then it comes to the nano. Is it nano is a new one or nano is the old one? So this is the very famous Lycurgus chalice, which is in 4th century AD. So you can see on the left side cup with a diffuse light and the right side cup with a focus light. That means even the 4th century people also using nanoparticle in their devices, but only during that time they didn't know that whatever the material they are using nano in nature, and they don't have the control over the material. They don't know how much they have to put, how much is ideal, how much is not ideal. Those kind of calculation they don't have, because now we have sophisticated equipments to tell that you have to put this amount of nanoparticles to get this kind of results. So the word nano is not a new one, but the technology is new. So there's a lot of nanomaterials present in nature, whether you take a gold nanoparticle, silver nanoparticle, carbon nanomaterial, everything. So to make it very simple, today I'm only talking about carbon nanomaterials because areca nut is mainly related to the carbon nanomaterial. As the definition knows, nano is nothing but anything which is less than 100 nanometer. And there is a two approach. I'm not going to give detail because not much time available for this kind of detail thing. But it's a two important approach. One is the top down. You start with the top and you end up with the down scale. Then another is the atomic scale to nanoscale. You start with the atomic scale, which is called as a bottom up approach. And these are the equipment used for synthesizing such kind of things. So when you have such kind of nanoparticle, what kind of application you can think of? So this is the spectrum of application. You can see the nanoparticle is here. You just draw a line here, then comes the textile. So where in textile, you can take a technical textile, medical textile, natural, electroconducting, anti-stain textiles, wound dressing. And if you take the biomedical, healthcare, food, agricultural, industrial, electronics, environment, and renewable energy. You can take any name, which is always possible with nanotechnology. So nano is such a powerful technology where you can almost do everything nowadays. Because of material becomes smaller and smaller, you can reduce the size of your final device also smaller and smaller, and you can miniaturization is much easier as compared with the available materials. Why we need to use areca nut for nanotechnology? Because areca nut is one of the prime crop of India, and it's also called as the supari or betel nut in India. It's also called a botanical name as Areca catechu, and you can see the Karnataka is producing 457,000 tons of areca nut. That is a huge production. And what areca nut contains? It contains of pyridine and piperidine, and also it's a constituents of polysaccharides, which is 50 to 60%, and lipid is 15%. Tannin, which is a very important. When you chew areca nut, you will get very it's a kind of feeling which is because of the tannin, which is polyphenols and also alkaloids. Why tannin is important, which you will get it in the next slides. So this is how areca nut, because areca, the very important thing is we always think that areca nut is from India, but in the Ayurveda, it is a date back 2000 years. It told that areca nut came from Malaysia, and then it is a part and parcel of Indian culture. So why it is very influence on market? Because of the weather conditions, because areca nut values are always fluctuating, because sometimes it is 200 per kg and sometimes it is 500 per kg, and farmer has to suffer because whenever farmer wants to sell the areca nut, the value of the areca nut is always low. So that is again, it's a carryover stocks, but again, the middle class family cannot keep this areca nut for a longer time because they want money for that year sustainability. And growth of the consumer industries and also government policies over the consumer industry. This all makes areca nut production is very difficult for the farmer because he always has to suffer for these things. And adding to that, one of the advantages of areca nut, has been called as anthelminitic, then nervine toxic and vermifuge for dogs, but also disadvantages. Recently, the Cancer Society of India told that areca nut is toxic in nature and it produces the oral cancer. There is no clear evidence for that, but they have given enough evidence to the Supreme Court of India, and there is a case is pending. And also they told that consume of areca nut in a longer run will give the reproductive issues. And some of the areca nut applications directly came into the market, like areca tea, which is released, and that is a disposable areca leaf plates from the areca. This one, areca nut plant, has been used, and betel leaves has been used for religious functions, so on and so forth. So many areca nut application, and major areca nut application is the chewing of gutka. And this is again the negative application from the areca nut. And because of that, farmers always afraid that government might ban this areca nut one day. If government takes such kind of extreme decision, it will affect several millions family directly or indirectly. So then we thought that instead of that, why can't we use areca nut for the high-end application like pharmacy, defense, energy, water, health, automobile, and aerospace, and the sensors. So this is the idea, because areca nut, one of the biggest advantages of areca nut, even if you want 1,000 tons of areca nut for the production of all these areas, it is available at one place. If you go to any areca nut association, they usually store several tons of areca nut, and it's always available. So that is a big advantage. No bio-waste or no biorenewable material is available in such a large quantity within shorter time. So it's very difficult to collect that kind of thing. But areca nut, we have that kind of storage unit available, and we can directly take tons of areca nut and converting them into a nanoparticle. So when you make such kind of thing, areca nut can be used only for gutka, or it can be used for unbreakable glasses, road construction. It can be used for pharmacy industries as a catalyst. It can be used for low-cost batteries. It can be used for low-cost electrochemical sensor. Water purification is possible with areca nut. Electronic vehicles is possible. Water filtration membrane is possible. Display technology, we can use areca nut. Writing boards, we can do with areca nut. And bathroom fittings, still counting. So many applications can be done, because this is the perfect way to say that we are doing this product, which is directly connected with the Atmanirbhar Bharat Abhiyan, and also it's a perfect fit into the Make in India. So how to do that? So why carbon nanomaterial? Because carbon nanomaterial is having, when you synthesize areca nut based nanoparticle, it usually combines with a mesoporous nature. What is mesoporous? If any material having 2 to 50 nanometer diameter, it's considered as a mesoporous. And when material becomes mesoporous, it is having different advantages, like it is having large surface area, specific capacitance, which is required for nanotechnology, is extremely high with these kind of material, easy to synthesize, and mesoporous nature, because nature itself has put porosity. Because usually whenever you are talking about nanotechnology, people will add the porosity into that. But here in areca nut, nature itself has added porosity into that because of the tannin groups. And when you heat such kind of thing, these porosity is transferred to carbon, and carbon becomes porous. Adsorption is extremely high, and bulk production is very easy in these things. So this is a very beautiful slide. It doesn't matter how many resources you have. If you don't know how to use them, it will never be enough. So the similar thing goes to areca nut research. It's not that how we see areca nut into that. It's only thing how we can bring changes to areca nut. That is what matters. So when you have areca nut, you first subject it to thermal gravimetric analysis, where you can see which temperature is ideal to synthesize the nanoparticle. I'm not going too much technical in this talk. So when you synthesize, then again, you might ask the question, why only areca nut? Because there is a lot of biorenewable material available, bio-waste material available, like onion peels, garlic peels, and so many leaves available in the nature. You can take any of them. Why only areca nut? So this is the answer for that. If you take any biorenewable, any bio-waste material in the nature, if you subject it to energy dispersive X-rays, energy dispersive spectra, you can see that carbon percentage is 75% in areca nut. If you take any other, it is less than 60%. So when you subject such a carbon-rich areca nut into a pyrolysis at elevated temperature, you end up with 98.2% of carbon and very small percent of sulfur and potassium. That is phenomenal in any of the bio-waste material reported so far. Because usually whenever you do these things, carbon percentage is maximum is 85 to 90%. And areca nut is rich with carbon, 98% of the carbon. and it is a low cost because it's only needs pyrolysis and the nitrogen atmosphere. And again, what temperature you have to do, because if you synthesize at 700 degree, 800 degree, 900 degree, 1000 degree, the carbon percentage remains the same. Then you might ask the question, then we can do only 700 degree, because going to 1000 degrees again adding cost to the material, because again you have to go 300 degree extra in the furnace. Then again your bottom slide gives the answer to that. When you have carbon 700 degree, your carbon percentage is 98.2. Where you go to the higher temperature, you will get the better carbon percentage like 98.54, 98.33 and all. So that's why you need a high carbon. And adding to that, the biggest advantage of going to the high temperature is the size of the particle. If you go for the 700 degree, the nanoparticle size is 100 nanometer. If you come to the 800, it becomes 60, then again around 58, then it becomes around 40. You can see 1000 degree, if you synthesize nanoparticle at 1000 degree, your carbon nanoparticle size is 40 nanometer, which is quite less and quite good. And when you have such kind of nanoparticle, it exhibits the perfect spherical shape. You can see here both scanning electron microscope and transmission electron microscope. It gives the perfect size and the perfect shape. That is really phenomenal in areca nut. No other bio-waste material is exhibiting such a perfect size in both SCM and TEM. So why areca nut is very important? Because of glycosidic linkage present in them. You can see COC glycosidic linkage at 1258 is ideal for these things. And when you synthesize, you will get CH, C double bond C band. This is too much technical for that, but you just remember it exhibits the glycosidic linkage. And what kind of surface area it exhibits? You can see it gives around 1000 meter square per gram at 1000 degree. This is again advantage of synthesizing areca nut at higher temperature. You will get high surface area. Because why surface area is important? Because when you have a high surface area, all your other properties are tuned along with the surface area. Whether you take adsorption, whether you take a specific capacitance, you need a very high surface area. So what kind of application you can think of when you have, so this is how you have to crush areca nut into these kind of powders, then you will get a very fine areca nut nanoparticle without any ashes, because we are removing all the oxygen and we will get very finest areca nut. So when you have such kind of areca nut powder, you can make supercapacitors, catalysis, membrane, water purifying kit, wound healing, antimicrobial, then automobile industry and CO2 global warming. We did all these studies. I'm not going to give more detail on this. If you are interested, please visit our lab. What we achieved so far, because we filed the patent on these things and we received more than 12 countries excellent research award on these topics. And I delivered several talks on areca nut based nanoparticle, and also we published a lot of this one. And we need a lot of collaboration, skill development, and because these kind of products needs a lot of support from every branch of science and technology. Even for the social platform like Rotaract Club, they can help us in bringing this product to the market. And this is the one very interesting areca nut nano. Why I'm telling all these things is, as I mentioned in the initial slide, the research, nanotechnology research through innovations. So when you have an innovative product, it's not only for one product. You have to see the same concept can be applied for various products. Then you can give value addition to the areca nut. That's the reason we expanded this areca nut seeds into various products. The one of the product is electrochemical determination of nitrite, which is very important because nitrate detection is one of the major concern, and this is the very interesting and very cost-effective way of determination of nitrate using areca nut nanoparticle. And the second thing is all these pharmacy and chemical industries, they are using palladium carbon supported catalyst for nitrogen reduction and Suzuki-Miura coupling by various methods. It's a very expensive because palladium is a metal and it's a very expensive material. So we thought that instead of palladium carbon, we will make palladium carbon nanospheres. And for our surprise, when you mix, when you reduce the loading of palladium, almost 50% lesser than what people are using, the yield is almost 99%, almost like a commercial material. That again tells that these areca nut based nanoparticle is having rich properties for commercial application. And this is another thing where we wanted to make a non-breakable glasses by using a particle reinforced composites, where you use the tensile properties of these kind of areca nut based nanoparticle. Then for our surprise, this is almost equal to commercial material. But again, we are using areca, and this is much better than the commercially available material. And also we used this one along with the Japanese collaboration. We studied the water purification, especially the dye removal of methylene blue dye we used. And this values is almost comparable to the commercial commercial nanoparticle adsorption. So that again gives some hints that this kind of areca can be employed for cleaning the rivers, cleaning the waters, and cleaning all the household water or industry waters. So this is the perfect way, because you are taking a farmer's areca nut, which is non-toxic in nature, because areca nut is a toxic, but when you convert that areca nut toxic into nanoparticle, because you are heating areca nut into an elevated temperature, then no toxicity is present, it becomes completely a non-toxic. So this is a nanotoxic to non-toxic approach we are using. And when you come up with such kind of thing, we can use this for ISRO, because today we are talking about Dr. APJ Abdul Kalam. We can use areca nut based nanotechnology for many DRDO, aerospace, or ISRO defense related project, because they need such kind of material which can durable, which can lightweight, and which can withstand for very high temperature, because these kind of areca nut based material can withstand until 200 degrees centigrade, which is ideal for many applications for defense related sector. So future of areca nut nano, we can, defense is almost $45 billion industry, health is $50 billion, water is 70 billion, and energy is 100 billion. Even if you take 5% of these industries, that itself is a huge, that itself is $1 billion industry for areca nut nanotechnology. If you take a future automobile where we can replace this areca nut nano, you can see already nano powders in paints for high gloss and durability people are using. Carbon nanotubes in windshields, but it's a very expensive technology. Nanoscale metal oxide ceramic catalyst, because to eliminate the emissions. Fuel cells with nano catalyst, and also membrane technologies, and nanopolymer composites for lightweight, high resistance bumpers. So all these things we can replace with areca nut nanotechnology, because it is a farmers friendly material and it is coming directly from the farmers. And this is the small device we made in our lab. You can see before and after 5,000 cycle. Even after 5,000 cycle, our LED glows very well. This again tells that this can be used for e-vehicles if we tune them in a proper way. And this is the non-breakable pipes we did. You can see the pipes here, very strong pipes we made. And also we made these kind of curvature glasses where we can drill a hole and no scratch is absorbed. You can cut it into several designs and you can bend it whatever the way you want. So in nutshell, it is a very rich dividend crop if you convert that toxic areca nut to non-toxic approach and diversified application. The farmers need not to worry about tomorrow their areca nut is going for gutka related application, because all the time whenever people are talking about areca nut, they always talk about it is being used for the negative application. If it goes to this high-end application, then we can bring a smile to so many areca nut farmers. Not only this, we can not only for areca nut farmers, later we can take many bio-waste material and we can see which bio-waste material is suitable for what kind of application. And these are all our success story. Recently, we have been highlighted by many newspapers where people have got interest about this kind of areca nut, where we can use this areca nut for defense application, then pipe application, then battery application, phenyl application, so and so forth. And before conclude, I want to tell very small ants rule book of life, which is very important, because today this is the Dr. APJ Abdul Kalam memory lecture. I want to tell, because all these things, one or the other way, Dr. APJ Abdul Kalam followed, and also he taught us about this. So when you tell about ants, when you are speaking about ant is going in a one line. And what this one line represents, the first thing is mind your business. We often like to talk about others. We, instead of doing our work, we always busy with others' work. We never think that what we are, and we always worried about what they are. So the ants tells that mind your business, because they are going in a one line. They won't bother about other things. Second thing is be brave, because you know how difficult time for the ants, because they are going in a one line and anything can happen when they are following in one line. So they tells that be brave, whatever happen, let it happen. The second thing is sense of discipline. They are always going in a same line, because they always follow with the line with the followers. Spirit of sharing, the ants share everything they get. Even if you see when ants take a rice, they always share and they will take it together with the help of others. Ignore diversions. There is no diversions in ants. They always go in a group. Prepare ahead, because ants are constantly preparing for the season which is yet to come. Because whether you take a human viewer, your priorities can sometimes be driven by what you feel like doing, but ants are not like that. Teamwork, if the material which they are carrying is heavy, then 5 or 6 ants comes together and they will help to carry these to the destination. Adapt to surroundings, because they know not every road is smooth, because they have a rough road, they have a water, they have all kinds of bumpy roads, but they know how to adapt the surroundings. And hard work matters, because ants are noted for carrying objects that are bigger than them, because no object is smaller than them, because they put the hard work to take that object to the next destination. One or the other way, we are all seeing ants following. We all see how ants are following, but this is the beautiful story where every moment of ants will help us to how we have to change our life, how we have to make our life better and beautiful. With this, thank you, Rotaract Club, for inviting me here for this Dr. APJ Abdul Kalam lecture. Although I have not told many things about technical, because since it is a memorial lecture, I avoided too much technical things, but I tried to give a glimpse of nanomaterials using areca nut, because it's a farmer's crop, and how we can help the farmers in one or the other way. Even small our efforts towards the upliftment of the farmers crop, I think that is the biggest thing we can give to the farmers, because whatever we achieve in nanotechnology should go to the farmers, because there is a lot of problems exist and farmers are suffering for a lot of technology issues. If we take these kind of technology to the farmers home, definitely we can bring smiles to them. Thank you so much.
Thank you, Dr. Gurumurthy Hegde, sir. Those thoughts were indeed inspirational and very thoughtful. I now request our club mentor, PP Rotractor Srinidhi, sir, to present the certificate.
I am a very small person to present to my guru. I have been fortunate enough to be his student in my post-graduation, and really happy to sit and listen to sir's class once again, or a lecture once again. And I could see the way the comments were, the appreciations were being given in the chat box. So on behalf of the entire Rotaract Club of Bangalore, Shisharipuram, and all the other co-organizers, we are very thankful for you, sir, for your time, patience in giving this particular lecture to us, and a lot of learning indeed. And thank you for being the speaker of event, and kindly accept a small token of love and appreciation from our side. A lot of appreciations in the chat box too. Probably we can take 1 or 2 questions before proceeding ahead. And this is a small certificate, and we also have another memento. I will meet you in person and hand over a small memento from our club to you whenever we meet you. So thank you so much for your.
It's indeed pleasure to receive memento from my own student, and that would be real pleasure to the teacher. Thank you, Mr. Srinidhi.
Thank you, sir. So there are some questions. Probably, I guess we have past President Rotarian Nagaraj Sringeri sir with us, who is well versed in areca nut farming. So Nagaraj sir, would you like to ask a question? I guess you have raised hand. We are not able to hear you. Sir, can you unmute yourself, please? We can see you, but yeah.
ಗುರುಮೂರ್ತಿ ಹೆಗಡೆ ಅವರಿಗೆ ತುಂಬಾ ನಮ್ಮ ಅನಂತ ಧನ್ಯವಾದಗಳು, ನಮಸ್ಕಾರಗಳು. ನಮ್ದು ಅಡಿಕೆ ವ್ಯಾಪಾರನೇ, ಹಾಗಾಗಿ ತಮ್ಮನ್ನ ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ಹೆಚ್ಚಿನ ಮಾಹಿತಿಗೋಸ್ಕರ ತಮ್ಮನ್ನ ಬಂದು ಖುದ್ದು ಭೇಟಿ ಆಗ್ತೀವಿ. ತುಂಬಾ ಸಂತೋಷ.
ಖಂಡಿತ ಸರ್, ಖಂಡಿತ.
Thank you, Nagaraj sir. And our club advisor, Meera ma'am, had put a comment in the chat box telling that Dr. Kalam must be nodding his head in appreciation wherever he is. And also we had an appreciation from Dr. Y. Ramlinga Reddy sir saying that we are proud of you, wonderful work for you and your team on nanotechnology. So thank you. I guess there is one last question we would take from Sandesh, Protractor Sandesh. Good evening, Sandesh. We can hear you.
Sir, is it economically feasible, sir? Like you said, nano on Areca nut, like.
Yeah, that is the one thing which many people are asking, because areca nut is always 400 or 500 rupees per kg, and when you make a device, whether it is feasible. But if you compare to other things, because we are planning now to reduce the cost of the other things, so that still we can keep the areca nut price. Our aim here is not to make areca nut to 1,000 rupees per kg. Our aim here is to make areca nut to sustain at 300 to 400 rupees kg for a longer time. Not for by bringing this technology. If we make 1,000 rupees kg, then no businessman wants to do business here, because today areca nut is 200 and tomorrow it becomes 1,000 rupees per kg, and businessman cannot sustain such kind of fluctuation. Definitely, when buyers are more, the cost will definitely reduce.
Thank you, sir. I guess that has answered the question. Once again, we thank you for your presence. Though you are not in station, I guess you are in IIT giving a lecture, and you have joined from out of the station, making time for us. Thank you for helping us conceive this idea of nanotechnology also as a theme of this particular year. And thank you so much for your presence.
Thank you.
I now hand it back to the moderators, Protractor Arpita and Protractor Navya.
Thank you, Club Mentor, past President Protractor Srinidhi sir. I now welcome Sergeant at Arms, Protractor Manasa Bhushan ma'am, to welcome our distinguished speaker, Professor Venkateshwarlu Dasari sir. Over to you, Manasa ma'am.
Yeah, thank you, Arpita. So, good evening, one and all present here for today. It's my immense pleasure to introduce our next speaker for the day, Mr. Venkateshwarlu Dasari sir. Venkateshwarlu Dasari sir did his BSc in Mathematical and Physical Sciences from Acharya Nagarjuna University, Andhra Pradesh, followed by Masters in Physics from Indian Institute of Technology, IIT Madras. And at IITM, he worked on magnetostringtic materials for sonar applications. Due to his strong interest in magnetism, he had joined Spintronics and Thin Film Magnetism Laboratory for the PhD program at the Department of Physics at Indian Institute of Science, IISc Bangalore, although he had got a central government job at BARC Mumbai as a scientific officer. At IISc, he worked on micro and nano fabrication methods and related technologies like thin film deposition, ion beam etching, reactive ion etching, etc., along with the characterization tools of SEM, AFM, Squid, magnetometer, and FRM. These are just a few to name. He published 5 papers in international peer-reviewed journals, along with 10 international conferences, workshops, and 4 scientific collaborative visits to UK and Europe. He was invited for talks in Italy and UK as a part of Indo-European project review meetings, including DSC meetings at IISc. He gave a couple of invited talks on micro and nano fabrications at Center for Nanoscience and Engineering, IISc, as part of RISE workshops. He is currently working as an assistant professor at Etria Institute of Technology, Bangalore. He teaches engineering physics to the students and always motivates the students for mini projects to enlighten the physics in engineering concepts. Also, Sir is representing Atria Institute of Technology in IUPEES training program to make the roadmap in reaching the goals of NEP 20 in engineering and education. A very warm welcome to you, sir. Thank you.
Thank you, ma'am. Thanks for the nice introduction.
Thank you, Sergeant at Arms Retractor Manasa Bhushan ma'am. I now request Professor Venkateshwara Dasari sir to address the gathering.
Yeah. Thanks for the nice introduction, and I'm glad to be here to follow the great speaker, Murthy sir, and I would like to share my screen now. Let me share. Yeah. Okay, I hope my screen is visible.
Yes, sir.
Okay, got it. So, so it's kind of continuation to the magnetic sensors. I mean, I'll be talking about the magnetism basically, but it's kind of connected to the nanotechnology. We are going to see how it is. So, Sir has already given some thought about a bottom and top bottom approach and bottom top approach. So we are going to see because from nanoparticle synthesis we see that atom agglomeration and all that you are synthesizing from small to big. And the other side, like fabrication, we will see from top to bottom. That means you fabricate something now and then you etch it and then make it into small particles or small devices. So basically that's what we are going to see. So before going for this, let me okay, slide transition. Okay, fine. Yeah. Okay, so I would like to thank Professor Srinidhi because he invited me to be a part of this program. So I would like to thank the remaining all the people, those who are there in the team of this RCBS, and I'm glad that I'm part of this the memorable talk by due to Dr. APJ Abdul Kalam. So let's see what we can cover. So I would like to be giving some a small introduction to the magnetic sensors, then evolution of magnetic hard disk industry, okay, in data storage. So all of us know, I mean, we are using this because many of us use laptop or hard disk in one or the other form. So that means every one of us are daily at least a couple of hours we are using this magnetic sensors. Okay, so we will see how and all in a couple of minutes. Okay, so we know that we are not stable on the globe, right? So we are just, let's say we are somewhere here and we are just not stable. We think that we are at rest position, but that is with respect to what? With respect to the Earth's globe, right? But Earth itself is not stable. I mean, it is resisting, it is spinning, right? So we call this as kind of a spin. And by considering clockwise or anti-clockwise, we just talk about some spin angle. So you may have up spin, like you call it as up, and down spin you call it as down. Okay, so just keep this notation in mind because we are going to say this at the electron level. Okay, in a couple of slides. So
sorry for interrupting you. I guess there is an echo. We are not able to hear your voice clearly.
Okay, just let me see. Thanks.
We could hear you, but there is some other sound which is obstructing your voice.
Am I clear enough, sir, now?
Yes, sir. I'm very sorry for disturbing your flow
no
of
problem.
thoughts.
I mean, it's good that you pointed out in the beginning itself. Otherwise, entire session would be wasted, right? Good. So now is it clear?
Yes, sir. Yes, sir. Please proceed.
So we are going to compare this spinning, so with respect to some spin quantum number for electrons. So just keep in mind this, that is what we are going to use it in spintronics, okay? So by the way, so I want to give this connection because, we know that, and we used to see these birds migrating miles and miles, even from northern globe, pole to the southern pole, or maybe, miles, one continent to other continent. So this kind of birds, I mean, when they're migrating, how they are actually tracing, so how they go back to their native place, or how they come back to the a place that they are already visited in the long time back, right? So this is the fundamental question what scientists are trying to understand from the ecological science point of view, and also at the point of navigation. Okay, so this is like, we know, I mean, nowadays we use Uber, Ola, everything they use the the map pointing, that's called we use the navigation map, right? So that's a Google map. I mean, how the birds are knowing that? I mean, how they are actually moving from one point to the other point, or how they come back exactly to back when the season changes, right? So that means they might be having some kind of sensor. So the scientists are trying to understand from the biology point of view, and then they realized maybe, I mean, some groups, there is a kind of debate when it a still unproved kind of situation comes. So we are some kind of studies are there on the biology point of view, where the birds might be having some kind of a neurological sensors, let's say within the brain, okay, and also in their eyes, where that might be made up of some kind of magnetic nanoparticles, okay, magnetic nanoparticles. If they are like magnetic nanoparticles are there which can sense the Earth's magnetic field, okay, when the Earth is precessing. So there is a Earth's magnetic field also, like from if geographic north is there, south is there, but magnetically there is a south pole here, and here magnetically north pole is there. Okay, that's how we see the bar magnet. When you keep it, it goes north goes to northern side, because there is actually southern point from the magnetic point of view. Okay, the bar magnet south pointing towards the southern geographically, but there is actually north, so it attracted by this. Okay, so like that, scientists are trying to understand what, I mean, the birds might be having either in their brain or in their eyes, or some body parts, wherever they can connect with the neurologically. Okay, so if they are having the magnetic nanoparticle inside, then depending on how they are getting the magnetic field sensing directions, then they can use that technology, or that knowledge, just like how we mimic, let's say when person is speaking, we without even seeing, we can tell that, oh, this voice is from this person, right? So that means we already got habited to that person many times, and we get kind of feeding, the memory is got fed in our brain. So like that, the birds also learn by ages and generations and generations, they got developed, and this kind of a knowledge in their brain. So that's what scientists believe. So similar to that, let's say now you go back and see most of us in the childhood, or maybe those who are senior members in the club now, or those who are present here, they may see that, okay, we used to hear in the magnetic tapes, right? So this is called cassettes. We call these are like cassettes. So these are the tape that is there here is actually made up of some kind of magnetic material. Okay, magnetic material. So that means when it is actually you record some voice. Okay, so when you are recording some voice in the present mobiles, there are no magnetic tapes like this. It is actually recorded by the voice and some apps, and then they decode the digital form. That means they actually have 1010 kind of digital form that is getting set stored in the mobile, and then when you read it back, then again it is coming back into voice kind of sound signal. Okay, by with some kind of hardware and software help. Similar to that, now the olden days, whatever the magnetic tape that they are using, it is actually magnetic material, and in order to make it as an information storage, that means you just have to mimic this kind of 1010 kind of memory, and for that you will be using some kind of a read head and write head here. The write head is going to have a feature which is going to erase the information what is already there, and then you write, if you want 1, you write it now 1. Okay, if you want 0, you write as 0. Like that, it is going to embed the information, and for that you have to use a magnetic material again, or let's say a magnetic field again. okay, because it's a magnetic material. So you're going to erase or write the information using another magnetic field or magnetic material, okay? And that is what it is called write head. And when you're reading back, let's say when the movie or some song is played in the cassette, so when the song is played, you hear the sound. So that information is coming from what? Already stored at a kind of information like this. And that information is now coming by read by magnetic read heads, okay? Magnetic read heads. So sometimes maybe those who have this experience, they may be if the song is not coming, they may go and then lift this gear here, and they may just clean it up with some solution or some so that it becomes like clear. So that means if any material that goes in between, then you cannot sense the magnetic information what is there in that tape, okay? So that means enough gap is there, and also if something is going in between interface, you cannot read the information clearly, okay? So this is how the olden days magnetic tape used to be used. And the next version, this is I don't know how many of you can believe it, but this is what the hard disk of first generation. So this is the hard disk which we used to see now in the palm, okay? The size that you can keep it in the palm. So earlier days, the first version of this, it is made by IBM, and they call this as IBM Model 350 disk, and it is having just 5 MB of data. Can you believe this? Just one song in these days, okay? If you just want to download something, it is going to be 5 MB data. That means to store that, you are downloading, or you are bringing a machine, and that machine is being shipped through the aeroplane, okay? So this is not used by any nanotechnology. So you should understand that the information was stored in just electromagnetic coils, and that's the reason why the size is so big, okay? And we are going to see how this evolution has happened. So this is how it is, okay? Then the next version is 250 MB hard disk, which is again a size of a person, and it is 1979, okay? And later the next versions, which is about 1 GB, the first 1 GB, again this is also you can see the size is something like a big machine, or some pump that you see in the engines, car engine or something like that, okay? This is 1 GB again. So 1 GB is something like you download one movie from YouTube, you get minimum 1 GB, let's say, okay? So that means you need this much kind of hard disk to store that, okay? Then this is what the next version. So you see that the size reduction has happened, and finally we could get within 1.8 inch hard disk. Nowadays you can get 8 terabyte, okay? So 8 terabyte is something like 8,000 GB. Now that means if this is 1 GB, 8,000 of such sizes, if you compare, and that everything, that entire things, you can just pack it in just 1 square inch kind of a chip, or let's say a size. But why the size is again formulated in this kind of system? Because you are not just storing the information, you want to read it, you want to again erase it. So that means a lot of other applications are the reading and back reading. So you need to have decoders, coders, and all that. So the electronic system, everything is having the size limitation. That is finally what you can make it. But if you ask only magnetic thin film that is required, then it is just 1 square inch is sufficient to store a very high density nowadays. And how that has been achieved? So this is how you can see. So earlier days, let's say if you want to read, so this is how your reader sensor, and if you want to even erase it and then write it back, so you just apply some current here, okay? Then you can create what kind of magnetic field you want. So if you reverse the current, let's say if you're flowing the current in this direction, you imagine you get north here and south there. That means this is going to be north and this is going to be south, right? So that means you can create the field in this direction. So the magnetic material will align when it is passing through this read head or write head, it will just align this way, okay? Now imagine if this is going to be other way, the current direction, because you want to write this now bit as not in this way, but you want to write it in the other direction. So you just reverse the current, then you get the magnetic field that is going to be here, it is going to be north, and here it is going to be south. So you get the magnetic field external magnetic field like this, that means you can create a bit like this. So now these bits are actually kind of 1 0 0 1, depending on how you decode it, okay, from the electronic point of view. Okay, so that's how the evolution has happened, and this is the main step to decrease the the bit size. So earlier days we know that the hard disk in the computer, it is going to be something like 250 GB or 500 GB, right? So like that it used to be in the hard disks, like laptops. Even these days we see that, but you can get with the same size now a 4 terabyte hard disk in the same size, okay, in the same size. So without changing any other dimensions, how it is we are able to store the information? Because earlier the technology was like you store the information in the longitudinal direction like this, but nowadays the technology is you are storing the information like vertical columns. Okay, so this is called longitudinal magnetic recording, and this is called a perpendicular magnetic recording. So the perpendicular magnetic recording means the bits are now up and down, okay, up and down. So how thin your sample is, let's say you keep your bit size is so small. Now let's say here it is going to be in the plane. So by the time you measure, let's say 1 unit of length, in that 1 unit of length, let's say 100 bricks kind of pieces you are keeping, and within the same 100 units of, now if you just rotate the bricks, you can keep a multiple more than that. Let's say the length to width ratio is something like 1:10, then you can see 10 folds increment in this density, right? So like that you can now achieve a more density of the information storage. That's the reason why we could see without able to see memory is increased, right? Okay, so in this, what we are actually today's topic is to understand what is a sensor here. Okay, so we know now that, okay, if you just inject, if you just pass the current like this, then you get northern kind of notation, or southern kind of notation, and based on that you can change the polarity of the bit that is there here. Okay, so each bit here is a kind of information that we are storing as ones and zeros like that. So that is being written by this right head, okay, right head. But if you want to read it back, let's say when you want you are just opening a file on your computer from the desktop, let's say. So when you're opening, and that information is actually stored as binary information like zeros and ones, but your computer is actually making that into a readable format for you in the ASCII format, like ABCD letters and 1 2 3s and all that. Okay, so in order to first store it, you are actually depending on the right heads, and in order to read it back, you are depending on the read head. So this is the read head. So that means what? Already there is a information. You are trying to understand whether it is up or whether it is down. So if you have some sensor here, and if it is able to detect whether it is up or down, that means your job is done, right? So that's the reason why this is called sensor. It is called sensor. And since the material is made up of magnetic material, so you call it as magnetic sensor. Okay, because it's obvious. I mean, since the magnetic material is the one that you are storing the information, so again, in order to detect, you need a magnetic kind of information. So because you are actually detecting the external field that is linkage here, so that is called fringing field, or it is a dipolar field. So that is what you are detecting from this read heads. Okay, so if you again further split it, and if you open this and then see what is there inside, so you will realize there is going to be a system called spin valve, or it is called a GMR, giant magnetoresistance, and nowadays what we see is TMR. Okay, so with the development of all this, we are going to see what these are terms and all in a couple of slides. Just be with me. So let's say the GMR structure is something like, you have got a magnetic material here, and you've got another magnetic material down. So this is imagine this is my wafer. So maybe silicon or silicon dioxide, something, you have a wafer, and on top of that you have first magnetic material, then you have non-magnetic material like a copper, gold, okay, copper, gold, or any other materials, okay, and then you have got another magnetic material. So let me call it as M1 here, magnetic material 1, and a non-magnetic material, and then you got M2, that is magnetic material 2. Okay, so the condition here is both of them should have a different coercivity. Okay, so for those who don't know what is meant by coercivity, just let me plot a simple plot. So this is called hysteresis loop. You might have studied this. So it is, let's say, H external field, and you are actually studying what is a magnetization. Okay, sometimes you will even see that this is going to be B, and they call it as BH loop. Okay, so let's consider magnetization is varying like this, and it is actually going in this direction. So it goes like saturation, and then it's, while coming back, you are coming in this direction, and you are going down. So it goes like this, and then in the reverse direction, you are coming in this way. Okay, this is how the loop goes, like this. Now in this value is called coercivity or coercive field, and that is HC, let's say. Okay, so this value for the first material should be different when compared to the second material. That's the first condition. Okay, so we are going to have different magnetic materials to have different coercivity. Okay, and why it is, we are going to see now. Let's couple of see. So let's say the electrons are coming from this direction. So electron has got a charge, we already know that, and it has also got a spin of it, right? So electron has got a charge that we know it is minus 1.6 into 10 power minus 19 coulombs. But in electronics, like whatever diodes or transistors or MOSFETs or any other electronic items, you are exploring only the electron's charge, but we are not utilizing its spin angular momentum, right? So in the spintronics, what we call a spintronics is actually you split that into spin plus electronics. Okay, that means when you are utilizing the spin angular momentum of electron in the electronics, so you're actually giving the term as spintronics. So that's basically tells that you need to utilize you are actually detecting even the electron spin angular momentum. Okay, now imagine electrons are coming from this direction, okay, into the material, and they have got a downspin. Okay, they've got a downspin angular momentum. So when they're coming like this, imagine the magnetic material is already saturated up like this. So since the electron is now seeing that, okay, this is opposite direction, so it will see, okay, there is a kind of a different behavior compared to when it is coming up condition. Okay, so that means the electron is going to detect inside the magnetic material what kind of magnetization is there, because they are coupled. So we know that electrons spin angular momentum is nothing but you also get a magnetic moment is related to a spin angular momentum. So because of that, we know that it is going to be scattered either in the favoring direction or opposite direction. Okay, so when the two magnetic materials are in the same direction, you will realize that it is going to be kind of a less resistance path compared to when both are in the anti-parallel condition. Okay, so that's how we are going to see in the system where you are taken two magnetic materials. Let's call this is M1, and you got M2, and there is a non-magnetic material. Okay, this was actually discovered by Albert Fett and Peter Grunberg, and they are awarded Nobel Prize in 2007. Okay, so the idea of that was earlier in the beginning days, the studies were limited to only single layer. Single layer means you got only one magnetic layer here, and you got non-magnetic, and then you got another magnetic layer. But what they did was to increase the sensitivity level. Okay, to increase the sensitivity level, they made this magnetic materials into stack form now. So you go like this, a multi-layer structure. It is called multi-layer. So you got M1 magnetic layer, non-magnetic, and M2 and non-magnetic, and M1. So like that, you are actually changing this entire, let's say this is kind of one sandwich. So this kind of sandwiches you are placing on top of each other like this to get a better sensitivity. Okay, so that's how they could increase the sensitivity. So with just one monolayer kind of system, you get the resistivity comparatively of this much, and with other extra layers, you could get even higher level. So by using even other materials like chromium and the other material. So basically this is you have to see that how the electron is going to screen from this to non-magnetic material. And in the screening process, it also looks for what are the density of states available. Okay, so that means it is all condensed matter physics. So I'm not going into the details of that, but basically the suitability of the material is also important. Okay, so that means you just have to play around. Let's say you have got understanding that you need two magnetic materials and you need one non-magnetic material, but you change this, so that's how the research goes. So you change the non-magnetic material from copper, gold, and then silver, and then chromium, like that. And somewhere you will find that, okay, there is a kind of, that's an experimental way. And in the theory way, you come back, like, you try to understand why it is. So at some point you will realize that, okay, theory and experiments are matching, and that's how you will, try to develop the technology for mass productions. Okay. So this is the system I was using for sputtering. So basically the thin film, when you want to deposit, so the thickness of this thin film is something around 5 nanometer. So whatever we are seeing there, it is something like 5 nanometer or even smaller than that, depending on how good your thin film quality is. And the non-magnetic material can be of, again, 2 to 3 nanometers or 5 nanometer, depending on the material again. So the other layer can be, roughly 5 to 10 nanometers or maybe 20 nanometer, depending on the material property. Okay. So that means altogether, your stack is going to be something like 5 plus, 3 plus, and then some 10 or maximum, even if you keep 20, then it's going to be something like within 30 nanometer thickness, right? 30 nanometer thickness. That means what? So if your sample is, you are going to deposit 30 nanometer, let's say, and you are seeing the cross section of that, imagine cross section of that. So it's something like this, imagine. So if your sample is not, smooth, and if it is having roughness like this, and when you're depositing the non-magnetic material, you will be depositing the non-magnetic material like this, imagine. Then the next magnetic material, when you deposit, it is not going to be, screened by this. That means the non-magnetic material is not fully, covering the magnetic material here. So the electrons will now go through the pinning centers, that is called, the regions where it is directly going from magnetic to another magnetic layer. So that means your system is not, capable for sensing the magnetic fields. So that means your system, whatever you are using it for thin film fabrication, either sputtering or pulse laser deposition or electron beam evaporation or thermal evaporation, whatever it is, the system should be very clean. It should be like, it should not have a roughness of more than, 1 nanometer kind of thing. Okay, even if you consider RMS roughness, it should not be beyond this. So that's how it should be very smooth, and then only you will get this kind of, sensitivity for the devices. So in the IISc, so we have the facility and we have a clean room. That means you will not get any even dust particles. So that dust particles can be of 1 micron size or even bigger than that, right? So you don't need all that. That's the reason why you need a fabrication, or you need some fabs. Okay, why even today, even in 20th century, we don't have fabs in India for fabricating the hard disks. So imagine, even if you go and, look into the Amazon or any Flipkart or anything, everything, like whatever the hard disk is, you are getting it is imported either from China or Taiwan or Japan, right? Or even US, because we don't have the technology. We don't have the fabs in India yet. So that means we have a lot of scope for all the engineering colleges or, the universities to make this as, for future generations, at least, we should bring the technology. That means by, what the other groups are trying from, nanoparticle synthesis, the similar way, the thin film deposition is something that is very important for fabrication kind of, mass fabrication kind of, technology. And for that, the first beginning step in the engineering colleges, I would say, a minimal sputtering or minimal thermal evaporation kind of systems. Okay, so I thought, today's talk is not just, giving what is there in the literature, but I thought, to give some kind of, message for us to have some kind of, brainstorming, like what we can start with, or, what we can go with. Okay, so since the magnetic field sensitivity is important, even for, not only navigation, and not only for even for rotation measurements, let's say. Okay, so rotation measurements, for example, if you are looking into the space applications, you would like to have a lot of gyroscope kind of sensors will be there in the rocket launching, or even when it is orbit put in the orbit. Okay, so you still, let's say a person is going and then going into the International Space Station, and they want to dock their spaceship to already existing International Space Station where there is an entry, let's say. So you want to dock this exactly to this system. Okay, then only you can open the door there. So for that kind of applications and all, you can use this magnetic sensors, and there are a lot of space applications. I'm not going into the detail because there is no time for in detail, but you will see that there is a good scope for this magnetic materials in space applications, and even the transducers. So in the beginning somebody might have remember the sonar applications where I was trying. So that is basically to look for navigation applications in the naval applications mainly. Okay, but the similar transducers you can even see in land rovers, or even that means once you land on the Chandrayaan, like mission, it is kind of a 90% success. But the remaining 10%, if you ask what this message is taken from ISRO website, this is a public message, so I thought let to keep it. So this was June 22, 2009. That means it is very recent, and most of us have seen this news when it was about to touch. That means when the lander was about to touch just 2 kilometers away, okay, from the moon surface, it got failed. That means we lost the communication, right? So there are a lot of requirement to land in a proper orientation. That means you need to know whether the orientation is proper or not before landing. Okay, so you can tailor all this by checking, because magnetic material is something that is kind of non-volatile. That means it is still active even the power is not there. Okay, but in order to make the data and everything, yes, you need the power. But what I mean is, compared to other electronic systems, magnetic materials are robust when it comes to a power failure or something. That's the reason why even your hard disk, okay, even if you switch it off, the computer or the laptop, the data is still there. Okay, that means it is called non-volatile memory. So this I think not only that, and even biology, like nowadays we are seeing the COVID and the vaccine preparation and all the pathology and all the detection for the bodies and antigens and all that. So even in the field of biology and medicine, this kind of stacks that you can use magnetic material, let's say 1 and magnetic material 2, you have got this kind of non-magnetic material, and based on, let's say, a particle is coming here and you pass the current, so it will see different kind of resistance. Let's say R1 is one resistant and R2 is another resistance, maybe like 10 ohms, and this may be like 20 ohms. Imagine that means it is 100% kind of change, right? So like that, you can achieve the change just by changing this non-magnetic material into insulator, that is called TMR, okay, tunnel magnetoresistance. So when you change the resistance, the in between that non-magnetic material from metal. So earlier I was telling it is either gold or copper or chromium or anything. So when you choose the metal, it is called giant magnetoresistance stack. And when it is insulator, like MgO or aluminium, okay, so it is called a tunneling magnetoresistance. Why is that? Because electron cannot go, let's say you have got a conductor and you have got a like insulator and you have got another conductor. So when the electron is passed like this, the electron is coming, so it says, okay, there is a conductor, so it will still go. Okay, when you apply the potential difference, it still sees that, okay, I can go. But when there is an insulator, it feels there is a lot of resistance, something like mega ohm, so electron cannot go. But when you change this insulator into something like 1 nanometer, okay, so 1 nanometer is something like 10 angstroms, you can imagine. So this is like a couple of mono layers. That means if you have atoms that are sprayed like this, and on top of that you have got another set of atoms, so like that you have got a couple of mono layers. They're called one monolayer if it is just one atom kind of thing, and then the second atom things you call second monolayer. Like that, you can have a couple of monolayers just to finish 10 angstroms, right? That means within this thinner layer, electron can now get tunneled that means it is actually quantum mechanics. Okay, so there is a lot of requirement from physics point of view, but when it comes to the material science, I think there are a lot of material science who are there in this talk. So when it comes to the material science, you need to tailor your deposition system such that it is going to be very flat. That means there is no roughness. So you need to tailor a lot of parameters like temperature, vacuum, right? That means pressure inside the system, right? So a lot of factors like including the composition of what is the material that you are using. So if it is a MgO, it's going to be one kind of a system when it sees the bottom layer as copper or cobalt. And if it is alumina, then it is going to see the chemistry is going to be different. Okay, so depending on that, you will see that there is going to be a different kind of roughness. So in order to have good sensitivity, we need to have very small roughness or completely flat kind of system, a thin level, which is of 10 angstroms or 1 nanometer kind of level. And once you have that, your system is very good sensor to sense even the atomic level kind of bindings that are going to happen in the system. You just keep them in some kind of bowl of solution, then you can detect, okay, what is the resistance change. Okay, so like that, I'm not good in biology, but I just thought keeping this picture because those who are interested can go through this. So basically you have got a GMR sensor here and you have got a bowl of solution, and in that you are going to see whether your reaction or whatever you are trying to detect, the antibodies, whether they are getting attached or not. Okay, all this you can study based on what is the resistivity of this. So this is a small chip, just like if you ask now diabetes patients, they can even check at home itself, right? So that small strip you are taking and then you are putting in a small machine, and then your blood drop is just injected on that. So like that kind of chips you can design, and you can detect what is a solution, how that is functioning. So these are called functional materials in biology, and you can use the magnetic sensors even in biology. Okay, so this is, most of us know this. So this is MRI scanning. So for these days also, during COVID time, we also see MRI is also kind of a detection for COVID purpose, right? So even for this, I just thought so for artificial intelligence, we are trying to understand the software wise. The same thing is now the other side is happening from the fabrication point of view, artificial intelligence based computers. Okay, so your CPU is now getting powered, or it is getting by a RAM or random access memory, and then it is being there is a CPU, and all the process happening at the chip level is basically only electronics. Okay, so if you can turn all of them into kind of spintronics related, then you can even make the circuits which are mimicking just like a neurons in the brain. Okay, that means you can think of a future computers which are just going to detect whether my A, B, when I'm writing here, let's say if your normal computer, you are doing the image processing, then you'll be doing the scanning from this end like this, and try to detect or try to mimic whether your letter A is matching with your database, that is A is given like this or A is given like this, just like how you do the thumb biometric access in your college, okay, in your university. So like that you are actually tracing these letters for matching purpose. But imagine when you are there in a gathering, like maybe IPL game is happening, not in the COVID time, let's say. So IPL game is happening and there are thousands of people in the gathering, let's say. But even in that gathering, let's say if you find to meet some person, if of your known person, you can easily guess, you can easily tell who is the name, or who is that person, right? So that means you are not actually scanning each and every person. So you are just directly telling who is that person by looking at that face. Okay, so that means our brain is adopted, and you are not actually scanning it like this. Even if I rotate the letter A like this now, our brain can detect and say that, okay, this is my letter A, but it is rotated up some angle like this, right? So in future, we are going to see all this. Right now, it is there, an artificial intelligence at the software level, but not at the hardware level. Okay, but imagine if it is there at hardware level, then you can have, or you can build the robots which can just be equally knowledgeable, just like human beings. Okay, with that I would like to wind up here. So thanks for giving me chance again. Yeah.
Thank you, Professor Venkateshwarlu Dasari, sir. I now request past President Retractor Apurva to present the certificate.
Good evening, everyone. So on behalf of President and the team RCBS, I present the certificate of gratitude to Professor Venkateshwarlu Dasari, sir. Thank you, sir, for sharing the valuable information.
Thank you, past president. And once again, thank you, sir, for being the second speaker and accepting on a very short notice. And you have given us a lot of insights and more technical aspect of how the physics students or master students who are here from the Department of PG Studies could take up their projects. And thank you for your time. And from the team of Road Track Club of Bangalore, Shesharipuram, we wish to present this memento to you. So tomorrow I will hand it over to you physically when I meet you in the college. So thank you once again for your presence and sharing of knowledge. So we hand it back to the moderators.
I now welcome Retractor Sushma to give a brief introduction about Y. Ramalingam Reddy, sir.
Thank you, Retractor Arpita. A very good evening to one and all present here. It's an immense pleasure to introduce our guest of honor, Dr. Y. Ramalinga Reddy, sir, the Associate Dean and Director of Civil Engineering, Reva University. Dr. Ramalingam Reddy, sir, has completed his BTech in Civil Engineering, MTech in Hydraulics Engineering, and PhD in Management. He has a working experience of 26 years in teaching, 5 years in research, and 4 years in industry. Areas of specialization: hydrology and irrigation engineering, watershed management, risk management, etc. Has published 24 national journals, 22 international journals, 6 national conferences, 8 international conferences, and 1 book. Has organized 25 workshops and attended 30 workshops, and has undertaken 2 R&D projects. Awards and recognition: Sir has received Lifetime Achievement Award, Dr. APJ Abdul Kalam Lifetime Award for Research and Teaching for the year 2017 from IISER Bangalore, Best Director Award for the year 2018 from Global Education Congress, and Best Teacher Award from SVCE Bangalore in 2008. We welcome you, sir.
I now welcome Y. Ramalingam, sir, to address the gathering.
Good evening, and first of all, I would like to thank you, Srinidhi and the team, so inviting me and for this very important event. So particularly, I am grateful to you. And if you see that our Gurumurthy sir, it is a really wonderful talk, and also even Venkateshwarlu has given more technical, but still it is really useful the current generation. Definitely, these two are the really excellent topics. No, you made me to at least sit and hear today evening. Really, I'm happy in spite of my other schedules. And another thing is, I'm also seeing almost, I can say that my mother age, Meera madam. Thankful to you, madam. You are just sitting in front of the camera and hearing the kind of continuously. I'm observing you, and you also just updating the each and minute to minute. So really, I'm thankful to you, people seeing such a great people today evening. And when you talk about that Abdul Kalam, particularly, and so of course he is the people's president, we can say, and a simple city and a common man who has reached to the highest position in the country. It is really, we had to be hats up. And fortunately or unfortunately, I can say that I got the 2 opportunities to live to hear his lectures. It was really amazing and wonderful motivator, what we can say, the Abdul Kalam. And fortunately, one of the Niti Aayog president has offered me, by seeing the contribution what me and my scholars has made, on the name of the Dr. APJ Abdul Kalam. Really, I am thankful to the entire team of Niti Aayog and his team recognizing me for this particular award. And when you come to the Reva University, in the Reva University, of course, most of the people are aware of, it is a multidisciplinary university and offering the, except medical education, each and every program we are running. And particularly when you come to the my school and School of Civil Engineering, we are running the BTech Civil Engineering and MTech, three important programs like computer-aided structural engineering, transportation engineering, and construction technology. And the research, particularly, we are working, most of our scholars are working on the materials, particularly, in the resources. When you talk about the resources, and I will take before going to in details a few points, I will highlight. And most of the time, when I heard some of the talks by the Dr. APJ Abdul Kalam, he used to focus, of course, we can say that missile man defense, that is another dimension what I have seen. And there is another dimension what I have seen from him. Always he used to stress about the three important points. Number one is education. We can say the Vidya. And number two is the what he used to focus on this one, health, that is a Vaidya. And number three, what he used to focus on is agriculture, Vyavasaya, what we can say. Vidya, Vaidya, and Vyavasaya. These 3 points, always he used to focus, of course, stress for Indian scenario. These two are the very, very important areas where our present generation, even in the research, and also our leaders, politicians also, they had to concentrate more on that. Then only we can claim that we are the developed nation. For this mass, of course, we can say the maximum population more than 140 crores right now. And so we required more on and healthcare, because we have seen already the COVID, how it has affected the last 2 years. So people have literally, we have just ideal in the house, of course. And another thing is education. Even now, of course, many universities like Reva and many universities, we are coming into the market. But unfortunately, still almost more than 7 lakh students of the Indian students are going to the abroad and studying. Why not they can continue here? That's what the Reva is focusing more on this particular area only. Why our students has to go to the abroad university? Our university is not inferior to any of the foreign university, either facilities wise and even of course, even education wise or curriculum wise and the quality of the faculty wise. We are not inferior to any other country. And only thing is, one thing I want to tell here is, if you go to any country, particularly in the developed countries, there is a government policy, and so government has to compulsory each and every industry, they have to tie up with the one university, and everything, the research, what is going to happen in the industry, they had to do it in the educational institution only. Unfortunately, in India, that system still has not developed. Even a couple of times, even whenever we are getting the opportunity to write the letters to our leaders, particularly even recently, one letter even we wrote to our Prime Minister of India also. And why not you can bring it one policy, and every industry has to develop their own research center in association with the one academic university, whichever the university they like. So this policy, when it comes to into the force, definitely we also on par to any other foreign university, definitely we can do it, we can excel. And anyhow, I thank the organizers, and so Srinidhi and your team and Meera madam, and so pranams madam. Really, I am seeing, and I am a small person to speak in front of you, but still, and you are hearing to just like your kid, you are hearing. I am really happy. And this is what actually any students of anybody is interested to join with the Reva, and please come on for the research scholars. And so we are here to guide, and so that these 3 focus areas where so Vidya, Vaidya, and Vyavasaya, and we are ready to help the students. And coming year, even we are going to start under the School of Civil Engineering, one more program we are planning to add, that is agricultural technology. And recently already the discussions has happened with our management. Shortly we are going to contribute in that area also. And Vidya and Vaidya, of course, Vyavasaya, both we are going to contribute. And shortly even our management may come into the market for this, particularly even even health also. That is even so education, particularly in the pharmacy and medical also. And anyhow, thank you, Srinidhi. So for inviting me to just to share on this important day and a few words in front of all of you. Thank you. Thanks. God bless you, all of you.
Thank you, sir. Thanks on behalf of Past President Apurva and our former Vice President Prajwal. All three of us are your students, and
Thank you. Thank you. God bless you.
It's the
God bless you.
encouragement which you have given us during our engineering days, which is leading us in this way. So thank you once again for being here with us in your busy schedule.
Thank you. Thank you. God bless you all.
Thank you, Dr. Y. Ramalingam Reddy, sir. I now request Protractor Kushal R to welcome Dr. Shashidhara Bhatt, sir. Over to Protractor Kushal.
Good evening, all. And it's my immense pleasure to introduce Dr. Shashidhara Bhatt, who is basically from Kundapura, and he has done BSc in 2005, Badakas Arts and Science College, Kundapura, and he has done PG in MSc Physics in 2007 from Department of Physics, Mangalore University, and he has done PhD in Physics in 2017 from Mangalore University with thesis titled Growth and Characterization of ZNO, Thin Film and Nanomaterials. And at 2000, from 2007 to 2008, he has worked as assistant professor in Department of Engineering, Physics, Karavali, Institute of Technology, Mangalore. And from 2008 to 2012, he has worked as junior research fellow, GRF, in BRNS DAE funded research project. And from 2013 to present, working as assistant professor in Department of PG Studies in Physics, Alvas College, Mudbidre. And he has also published 18 papers and 1 patent in national and international journals. Thank you.
Thank you, Protractor Kushal. I now welcome Dr. Shashidhara Bhatt to welcome and address the gathering.
Thank you. We are happy to associate with you for this webinar. Really wonderful session. Both the sessions are very good and really interesting for our students and our department. Behalf of our department and students, we thank Rotaract Club Sheshadripuram, Bangalore, and the School of Civil Engineering, Reva University for conducting a good webinar at this evening. Students have a very keen interest in the, especially the magnetic material, even my interest also. And also as Ramlinga sir said, Vaidya and all those things, Abdul Kalam sir was interested in that. So in this regard, I thank all the members of Rotaract Club and the members who have arranged this webinar. In future also, we will associate with you and continue this journey. Thank you all.
Thank you, sir. It was indeed a pleasure for us to get an association with Alvas College, Mudbidri. We know the giant feat of Alvas College. And on this platform, I also wish to thank Dr. Jairam sir, who introduced you to me, and through whom we could get this project done and this association happen. Thank you for the support which you have been providing since the day we spoke. It may be in helping us lend the web portal, or also it may be through helping us get the students who have stayed back almost till the end of the event, I would say. So once again, on behalf of RCBS, I would like to thank you for your support and continuous support indeed. Thank you so much, sir. Thank you, Arpita.
Thank you.
I now call upon Secretary Rotractor Rakshit K. Shetty to deliver the word of thanks.
Thank you, Rotractor Arpita. Good evening to one and all gathered.
Rakshit, sorry for stopping you. I think any event is incomplete if Meera ma'am doesn't give her best wishes to us. So I know if even if ma'am is not ready, but on this platform, I request Meera ma'am to address us once and shower her blessings upon us.
My energetic friends, I really enjoyed the session. Dr. Gurumurthy Hegde's, I understood very well. And Mr. Dasari's, it is too technical, but I knew that he is doing something. This thing, my physics is limited to my intermediate physics. That is 56. Okay, and always I used to think this cancer and decay. What are these farmers going to do? As he said, you must find different uses of the naturally available materials which will be attractive for the growers. I will put it as growers, not agriculturist or horticulturist, to the growers. Any job should be attractive to them. So that was very, very interesting to me. I'm in the agriculture input industry. So I really honestly heard every word he said. Dr. Dasari is too technical. And I was while listening to Dasari, I heard it like in a college lecture, 1 hour lecture with all concentration I had, because I wanted to absorb as much as I can. Research and development should be it should be attractive for the researchers, but ultimately roti kapda or makhan, no? So if that is properly provided, their passion for research cannot be doused. That should be attractive for them. And he said so many materials are being imported from China and other things. When is it the materials are not available in India, available in China, I wonder. But ultimately, like Narendra Modi said, make in India, export to the other countries. And I don't like developed countries. All the countries are developing only. There is no stop in developed. No, developed means full stop. No. Everybody is developing. Every country is developing. Every technology is developing. So don't use developed countries. All countries are developing countries only. Agriculture should become attractive. Abdul Kalam's, his passion is infectious. Infectious. He used to take, when he was president, he used to call all the MPs and all those people and give them a program and will make them give a progress report. Progress report. Just like college days and examination and all, at least those fellows started thinking what I am doing. What am I doing? So that is the thing. I am a great admirer of Abdul Kalam. And that is the reason everybody I heard. But we should give research and development priority, and the researchers should be monetarily compensated to keep them there. Can you hear me?
Yes, ma'am, we can.
Can you hear me?
Yes, ma'am, we can. Are you able to hear us? Can anyone please leave a message in the chat box?
Can you hear me? You can hear me?
Yes, ma'am.
Okay. I love my country. First, I love my place. I love my home. I love my city. I love my country. I love the whole world. The whole world should have peace, development, and should be any innovation invention should be used for the welfare of the whole world. That is my passion. That's my passion. It should not be commercialized. It should not be commercialized. Like sun, moon, it is there for everybody, no? Like that, any research progress should be shared with everybody. Thank you very much for giving this opportunity. I really enjoyed the session. Physics, little I understood. And I always tell when people say, you are short, you are small and all, I always used to tell them, you fellows don't know, God made me nano. I used to tell them. And thank you very much. Thank you.
Thank you so much, Meera ma'am, for your continuous support and inspiration, inspiring to us as always. So that is our club advisor, Rotarian Meerabai Shankar ma'am, one of the only, I would say, at present, she is the only manufacturer of liquid fertilizer and agricultural products in India, and a gold medalist in her BA and MCOM, and who stood with her husband, late Shankar sir, and took up Panchajanya Enterprises to a great height, and also a humanitarian by service. She has been in the field of service for over 4 decades. So thank you so much, Meera ma'am, for your continuous support, blessings. Yes, ma'am. Yes.
My husband is the innovator of this idea. Liquid fertilizer. Now, so many people are manufacturing. He thought about this concept, developed it. He had a patent. He refused to exercise his patent rights because he said India is a agricultural country. And how much can I take this to people as one person? Let so many people copy it. Let so many people use it. Let all the farmers benefit by it. And I'm not MCOM, I am MA, BA and MA. BA and MA. Shankar holds the patent for this product, but we never exercised our right. We never exercised our right.
Thank you so much, Meera
One
ma'am.
more thing.
Yes, ma'am.
When this product was just introduced, somebody in Kutch, we used to send money, we used to send the product. Later on, we realized all that product that dealer was intending, it has crossed the border and gone to Pakistan. They used it for the grapes. And okay, I have a fulfilled life and fulfilling life until I'm like this, I'm happy.
We pray the same to see the smile on your face always, which keeps inspiring us day in and day out. Thank you once again, ma'am. I could recognize the presence of many dignitaries here. We couldn't request them to talk, but I can see Dr. Arun Balodi, sir, HOD of Department of Electronics and Communication. Sir, if you're free, if you would like to address us for a minute. I would like to take this opportunity to thank Dr. Arun Balodi sir and Department of Electronics and Communication for supporting this particular project. And I could also see many Rotarians joining us, past President Rotarian Nagaraj Shringeri sir, past President Srinivasa sir, who was here. Till now, he was attending and listening very attentively, and past President Rotarian Yvonne John Daniel ma'am was also listening to us. And we had with us PDG Mangaraj sir, and we have been just joined by PDG Ravi sir. So wish to thank all of you for the support which you have given, and would like to take, I see President Lavanya, technically she is unavailable to talk to us, but she has sent her wishes and wish to share you all the wishes and the gratitude that today's event was successful. Thanks to you all. Thanks for the continuous support which you have been providing. Thanks to all the Rotractors who have worked day in and out, especially because of my busy schedule. I couldn't work much this time, but the entire Rotract team ensured that it is a very, very smooth program. Thank you so much for this. And thanks to all those who helped us by collaborating with us, and to all those who supported. It may be Arena Animations or ThinkWorks, or it may be KSTA. Dr. A.M. Ramesh sir was also with us for a very long time. And as I said, HOD Dr. Arun Barodi sir is also, who is here from ATI Institute of Technology. And the collaborators who helped us organize, and the resource persons, I'm very thankful for you for helping us ensure this 4th annual Dr. APJ Abdul Kalam Memorial Lecture was a very successful one. And we would await for the next 5th one with a much bigger crowd and another very interesting topic. And I guess I had taken enough time from Secretary Rotractor Akshit. So to my young dynamic leader, I hand over to you to propose a vote of thanks.
Thank you so much, sir. Good evening to one and all gathered here. On this wonderful evening, I would present the vote of thanks. I take this golden opportunity to thank our respected guest speakers, Dr. Gurumurthy Hegde sir and Professor Venkateswaralu Dasari sir, for taking time out of their busy schedule and presenting an enlightening and entertaining presentation on nanotechnology, research and innovation. We owe you a special vote of thanks for being here, sir. I extend my heartfelt gratitude to all 3 guests of honor for being with us this evening. Thanks to Dr. Shashidhar Bhatt sir, thanks to Dr. Y. Ramalinga Reddy sir, and thanks to our club advisor, ever energetic Rotarian Mirabai Shankaran for joining. I thank Dr. A.M. Ramesh sir for joining this evening. I would like to thank the President of Rotaract Club of Bangalore, Seshadripuram, Rotractor Lavanya, for joining this evening. Thank you, President. I would now like to thank the Chair of Event, Club Mentor, Past President, Rotractor Srinidhi SU, for his leadership in taking forward the Dr. APJ Abdul Kalam Memorial Lecture for 4th consecutive year now. Thank you so much, sir. I also wish to thank the past presidents of RCBS, past President Rotractor Nishit Prabhakar, and past President Rotractor Apurva NH for joining the session. Thanks to Rotractor Akash Lep Chetty, the Director of Professional Development Avenue of RCBS, for his leadership throughout the project. I also thank the Board of Directors of RCBS, Sergeant at Arms Rotractor Manasa Bhushan, Community Service Director Rotractor Sushma Suresh, and Committee Chairs Rotractor Prajwal Balaji, Rotractor Sagar, and Rotractor Ashwini. I also like to thank Rotractor Arpita and Rotractor Navyashri for wonderfully moderating the event, Rotractor Bharat Krishna, Rotractor Kuchal, Rotractor Nayana, Rotractor Sandesh, and Mr. Pranav Bharadwaj for coordinating with the team. I also wish to thank all the collaborators and supporters. Many thanks to Department of PG Studies in Physics, Ardas College, Moodvidre. Thanks to School of Civil Engineering, Reva University, for collaborating with us. Thanks to Department of Electrical and Communication Engineering, ATRI Institute of Technology, Karnataka Science and Technology Academy, Royal Concord PU College, Kalyanagar, Arena Animations, Bangalore, and ThinkWorks Games and Animation for all their support. Many thanks to all our participants for joining, to the members of RCBS, Rotractors, and Board of Directors of other Rotract Labs for attending the session. With that, I end my vote of thanks. Thank you all.
Thank you, Rakshit. I once again wish to place a thanks to you too for the wonderful leadership that you have shown throughout this session. And also would like to thank once again the Rotarians who made it possible for us to make it a very successful event. It's a great honor to have PDG HL Ravi sir also joining us. So thank you so much, sir. And we wish to have your presence in the coming days too for all our events. And thank you to the entire team of RCBS. I hand it back to our moderator, Rotractor Navishri, who wishes to close the event with a quote, and then we would end the event. Thank you all once again.
Thank you, sir. So ending this wonderful session on a high note, we are all looking for the magic formula. Well, here you go. Creativity plus iterative development is equal to innovation. Wishing all our young scientific minds here all very best for your future endeavors, and may you all find this magic and reach towards all your innovations. Thank you, and wishing you all a great week ahead.
Thank you, Navya. Thank you, everyone.
Thank you all. Good evening.